Okay, so having a look at question 1, again we've been asked to work out the vector which has translated our shape. So just like I've shown you previously, if we draw out this picture at the start, it will make questions like this a lot easier. So remember, if we're going to the right, it is a positive movement, left negative, and that first number is our horizontal movement, and then the second number below that is our vertical movement. Again, positive going up, negative going down. So it's asked us to show how we've gone from shape P to shape Q. So I'm going to pick one point of my shape. This has to be the same point. Then we're going to count how many squares it's moved to the right. 1, 2, 3, 4, 5, 6. And how many it's gone up. 1, 2, 3. So therefore, my vector is 6, 3. So question 2, it's asked us to work with vectors. We've got negative 2 times by this vector g. So we've got to do negative 2 times 3, which is negative 6, and negative 2 times negative 1, which is positive 2. Part B asks us for f, which we already know, plus 3 lots of g. So again, I'm going to work out what this 3 lots of g is first. 3 times 3 is 9. 3 times negative 1 is negative 3. So our question then becomes negative 2, 4, plus 9, negative 3. So negative 2 plus 9 is 7. So that's our horizontal movement. And then 4 plus negative 3 is 1. Again, our vertical movement there. Our final question, part C. We have got 2 lots of f minus 4 lots of g. I'm again going to work these both out first. So 2 times negative 2 is negative 4. 2 times 4 is 8. Now this next part we've got to be careful. I'm going to keep my negative sign and only multiply by the 4. So 4 times 3 is 12. 4 times negative 1 is negative 4. So now we're going to collect these together. We've got negative 4 subtract 12. That gives you a total of negative 16. 8 subtract negative 4. We've got 2 negatives together, so it becomes a... So, looking at question 3, the key point to remember here is because we've got this parallelogram, that our diagonals are equal in length, so AO is equal to OC, and they are a straight line, so have the same gradient, therefore the vector is identical. So because AO is equal to this vector A, we now know that CO is also equal to this vector A. Similarly, for our other diagonal, we know that because O to B is this vector B, then D to O must also be this vector B, because it is the same size and has the same gradient, because they're both on the straight line. So we can label that in as vector B. Once we've completed that, we've got all the information which now allow us to answer this question. So it wants us to work out the vector CA. So in order to do that, we need to go from C to O and then O to A. C to O we have labelled on is the vector A plus the vector A again. O to A is A, and that gives us our final answer of 2a. Part B asks us for the vector A, B. So this time we're going to start at A and go to O, and then we're going to go from O to B. So A to O is negative A. We're going in the opposite direction of the arrow, therefore our signs are changed and flipped. So instead of positive A, it becomes negative A. Then from O to B is our vector B. We can't simplify that, so that's our final answer. Finally, we're going to look at the vector BC. So to go from B to C, we're going to go from B to O, and then from O to C. So here, B to O is negative B. We go in the opposite direction of the arrow. And then O to C is negative A as well. Right, so in question 4, we need to work out what the vector DC is. At the moment, we cannot do that until we've used our ratio. It tells us that DC to AB is in this ratio 3 to 2. We know what the length of AB is. That is that vector P. I'm going to show you a slightly different way to what I did previously. So here, DC is represented by these 3 boxes. AB is represented by these 2 boxes. I know that AB is equal to this vector P. So therefore, in each box must be 1/2 P. And if we copy that across to our DC side as well, that now tells us what the length of DC is. And that is 3 over 2 P, or 1.5 P. I know a lot of you prefer to work with decimals rather than fractions. So here, DC is equal to 1.5 P. If you think back to how I originally answered that question, we said that actually we just needed to times our AB length by 1.5 in order to get our answer for AB. That method works perfectly as well here. Part B then asks for us to work out the vector BC. So I'm just going to label on what we've worked out in part A. To go from D to C is 1.5 P. And like I've shown you in a lot of other videos now, the direct route to go from B to C is there. However, we don't have any information about that line. So, unfortunately, we have to take the long way around. But because we're still going from B and arriving at C, this is perfectly fine. So like you've seen previously, I'm just going to write out the route that we're going to take. So to get from B to C, we are going to go from B to A, then from A to D, and then finally D to C. And if I fill in that information now, B to A is negative P, because we're going the opposite way to our arrow. A to D is our vector Q, and then finally D to C is that vector 1.5 P. Again, you might find it useful to fill in the imaginary number 1s. Then we just collect together our vectors. So negative 1p plus 1.5p is going to give you 0.5p. And then we've got our 1q left over. Okay, in question 5, it tells us that ABCD is a parallelogram. This information is key because now we know the opposite sides are equal and also parallel. So that allows me straight away to fill in this information that C to B is equal to this vector A, and A to B is equal to this vector C. Now we've done that, we can read the question. Find in terms of A and C the vector m to n. So the next part of information we're going to use tells us that m is our midpoint of CB and n is the midpoint of AB. So therefore, to go from m to n, the route we're going to take is m to b plus b to n. We know that the total line C to B is equal to our vector A, and m is the midpoint. So therefore, m to b must be 1/2 A. Similarly, we know that the total of AB is our vector C. However, we're going from B to n, where n is the midpoint. So first of all, we're going in the opposite direction, so it's a negative, and then it's going to be 1/2 B. In order to show that two lines are parallel, we need to work out the vectors for both CA and MN. The lines which it's talking about you can draw in if this helps you visualise it. So there's our line CA, and here's our line MN. So let's now work out our vectors. So C to A. In order to go from C to A, we are going to go from C to B, and then from B to A. You could have gone from C to D, then D to A, and you would have got exactly the same answer. So C to B is our vector A, B to A is our vector negative C. MN we have done above, where we got our 1/2 A minus 1/2 C. Now we've got our two vectors and we're trying to compare them to prove they're parallel, we have to try and take out a multiple so that we can show that the vectors are the same. So if we're looking at MN, we can take out 1/2, and inside the bracket leaves us with that vector A subtract C. So that now tells us that our vectors are parallel because the vectors are the same inside the bracket, and it also tells us that MN is exactly 1/2 the size of CA, which again, if you look at the diagram, looks about right.